welcome to the practical activities of this course. We're about to embark on a super huge journey, but yet a very exciting one because we're going to build together a series of machine learning models from all the branches of machine learning. And speaking of these branches, you have them in front of you. That's the whole folder of this machine learning um, course, and it is structured into all the different branches from data processing, regression, clustering, association rule learning, reinforcement learning, and deep learning. Now, we're about to start part one, which is data pre-processing. And this is the first very important step of this journey because indeed, anytime you build a machine learning model, you always have a data pre-processing phase to work on. You have to pre-process the data in the right way so that the machine learning model that you're going to build can be trained the right way on the data. So we have to start with this step. This will not be the most exciting step, but we will make sure to do this very efficiently so that we can rapidly proceed to the branches of machine learning where we're going to build indeed some models. But before that, we have to master data pre-processing. So first of all, make sure that you have the same as what we have on this computer right now. This is the whole machine learning codes and data sets folder containing all the Python codes and all the other codes as well as all the data set in each of the practical activities we're going to do together to link of this folder. The link of this folder will be provided, and if we are on the same page, then let's do this. Is get inside this folder. One day will be So this folder is structured into folders for Python and then R. This Python for the content for this course will be using Python implementation. And these are for the content of our implementations with the same data set. So now we're gonna go into Python because each time you're in each section, anytime we build a model, we're going to start with Python. So we're gonna teach you all the tools on data pre-processing, and you will find this folder in Python folder. You will first find this data pre-processing tools implementation, which contains all the different tools that you might have to use on your data sets in order to pre-process them the right way for your machine learning model. Then we have the data pre-processing template, which will be very useful for us to tackle any data processing phase of our future machine learning model implementations in the uh, next part. We'll also have this data in CSV file that is CSV, which is the data set on which we will show you how to implement all these data processing tools. And to give you some context, let's say that this data set belongs to a retail company that collected some data from their customers, whether or not they purchased a certain product. So here, each of the rows correspond to different customers, and for each of these customers, this company gathered their country, their age, their salary, and whether or not they purchased their product. So that's a simple data set. Now, we suggest that we start this data um, because indeed this course is really action based. You're going to learn by doing in this course, and therefore, for this implementation, each future implementation, we will re implement from scratch. Our first implementation will be for all the data pre-processing tools. We're gonna open this file, and in the first section of this course, you can either open it in Google Collaboratory or just double click here or on Jupyter Notebook. If you don't like Google Colab, you can or feel free to select your most comfortable environment. First, uh, this is the whole implementation. Let's scroll down a bit. As you can see, you will get many tools. Let's have a look at them one by one. The first thing is how to import the libraries. These are the libraries we'll always use in the machine learning implementation. We'll include them in the template so that they can be ready to use for our implementation. Next is how to import the dataset, that exact same dataset which we introduced to you a few seconds ago. That dataset, I will show you how to first upload it in Google Colab, then import it in your Python file. That's the second step. And then next is how to take care of missing data, because indeed in most of the data sets you work with your machine learning career, you might encounter some missing data, and that's the case here for our data set. There is a missing salary here and a missing age, and they will teach, and we want to know what to do in order to handle this. After taking care of the missing data, we will teach you how to encode categorical data, whether it is the independent variable, which is your prediction or predictors, or the dependent variable, which is what you want to predict. So as you can see in our data set, we have two categorical variables. The country column containing indeed three categories: France, Spain, Germany. Then numerical values in the other variables. We have this category called variable containing two categories, yes or no. Then what to do with that situation so that then you can be ready to pre-process any data. We will teach you how to split the data set into the training set and the test set. And that step is very important because each step you want to train a machine learning model, you will have to create two separate sets. One training set where you're going to train your machine learning model to understand the correlations inside your data set, and one for the test set that you're gonna use to evaluate your model, and then therefore on new observations, because a test is like new data on which the model wasn't trained. That's very important to do. This is uh, in order to check that indeed there is not overfitting. Next is we will introduce the feature scaling, which actually scales all your features to make sure they are on the right scale. So you won't have to use that all the time. We will see in each of the implementation whether we have to apply features scaling or not. And we have to include this feature scaling tool in the data pre-processing toolkit because we'll have to use it from time to time. So that's the table of contents. We're going to re-implement all this from scratch. However, if you feel you're comfortable with all these tools and you understand them already and you can't wait to move on to the implementations, feel free to just read this code and make sure you understand it 100%, and then move on to part 2, which is regression, where we're going to build our first regression model. However, we're going to re-implement this, each and every single one of these tools in the next, um, in a few moments. And to do this, because remember that this tool is actually in read-only mode, we'll have to uh, create a copy by clicking File here and then save a copy in Drive. Create a copy, then re-implement all those codes from scratch. So we're gonna remove all of them, each one of this, by clicking this trash bin here. But make sure not to remove the labels. Remove only uh, the code cells. So that's the outline. of the whole implementation. So it's very important that you understand well the implementation. Whenever you're ready, let's start from the next um, demonstration. And now we're going to tackle very quickly the first step of this toolkit, which is the libraries. How to import the libraries, how to have them ready anytime we start building new machine learning model. Um, it's actually very simple. We're going to import three libraries now, which are known by Matplotlib and Pandas, and it will actually allow us to work with arrays because you will see that your future machine learning models will expect some arrays as inputs, and therefore we need the library to work with these arrays. And that's not by then we'll import matplotlib, which is the library that will allow us to plot some very nice charts. Then pandas, which will allow us to not only import the data set but also create the matrix of features and the dependent variable vector. So let's import these libraries. We just start with import. That's the command that will allow us to import the library or even a function or any type of module. By the way, a library is a symbol of modules containing functions and classes with which you can perform some actions and operations. For example, the most well-known library in data science is scikit-learn, and this is a library that contains actually all the machine learning models that you can build by simply creating an object of some classes. Now we will see that in great detail each time we build a machine learning model. But there you go. You will see the library will be surely useful for us in order to build our machine learning model. The first one we want to import is called numpy. And in order to call it faster, well, we can add a shortcut here so that each time we want to call, we'll actually call it with its shortcut np. And the shortcut we usually use for an And the shortcut we usually use for NumPy is NP. And as you can see, at the shortcut to simplify it, and as uh, we use the AS and then the shortcut name. So each time we will call them, we actually call NP. Then next library import, so that library is matplotlib. So here we're not only going to import matplotlib, but particularly, well, the pyplot module. And as you can see, in order to get this pipeline module, I added a dot here which allows you to access the different modules of the matplotlib library. And the modules we choose is by plot, pyplot. And we're going to add a little shortcut here, which we're gonna call PLT. That's the usual name for the pyplot module. We're going to import the final library, a super useful library to pre-process your dataset and mostly to import them. And same for this library, we're going to add the simple shortcut name PD. Next, we will be importing the dataset. Now let's learn together how to import a dataset. As a reminder, we're going to learn how to import the following dataset. That's CSV, which is a very simple dataset of a retail company that's doing some analysis in which clients purchased one of their products. So the rows in this dataset correspond to different customers of this employee, and the for each these customers, we have their country, their their age, salary, and whether they purchase or not. So we're going to import this CSV on Python using, of course, the Panda library. First, create a new code cell, and then let's import this data set. We have to do is create a new variable, and this variable will contain exactly the data set. Choose simple names for the variables representing what we're creating, and therefore, since now we're importing the data set, we want to integrate the data set in a variable. We're gonna call this variable data set. This variable will be equal to the output of a certain function by pandas. And the certain function will exactly read all the values of this dataset and create what we call a data frame. It's a certain format of data, whether it is in Python or even in R. It will create a data frame and it will contain exactly the same rows and columns and the values as what you see in your dataset. In order to create this data frame, we're going to call a certain function by the pandas library called read on. This is read CSV. We will only have to input the name of the dataset with the extension. We're about to call a function of pandas. The first thing we have to do is call the pandas library. Since we give it to the shortcut name PD, in order to call it, we need to use PD, and then call a function from the library, we need to add a dot. It's always done that, and that's where you can call the function you want to use. Then uh, the function is read CSV. And then you add some parentheses to enter the argument. You have to input in quotes the name of the dataset. As a reminder, the name of the dataset is data with a capital D, D dot CSV. So that will create a data frame, all the values inside this data set, and this data frame will be exactly the same in the dataset variable. That's the first step. That's not enough to import dataset as a first step of data pre-processing. The next thing you have to do is create two new entities. The first one is the matrix of features, and the second is the dependent variable vector. So let me show you exactly what they mean. The very first important principle in machine learning in any data set with which you're going to train a machine learning model, you have the same entities, which are the features and the dependent variable vector. What are the features and what is the dependent variable? The features are the columns with which you're going to predict the dependent variable. And the dependent variable, of course, is the last column because you know this company would like to predict if some future customers are going to purchase a certain product based on these informations. Very simply, the features, or also called the independent, are the variables containing some information with which you can predict what you want to predict, which has got the dependent variable. So remember this very important principle in any machine learning that you're going to build. You're going to have separately the features, usually in the first columns of the data set, and the dependent variable, usually in the last of the data set. All the data sets will use this course, and most of the data sets you'll use will have the same format with first the feature in the first column and the dependent variable vector in the last column. So the right, so we want to create the two entities we want to create are first the matrix of features containing separately these three columns here in the country, salary, and separately we want to create a dependent variable vector containing only the last column because that's the column we want to predict. And that's exactly what we always have to do in this first day to pre-processing phase. Let's create these two entities and we're going to call them X for the matrix of features and Y for the dependent variable vector. Starting with X, how are we going to create X? We have our data set containing exactly all of these columns. And in order to create X, we simply have to take the three first columns of this data set because x will be exactly all these values here with the three first columns. And so what we're simply going to do is play with the indexes to collect indexes of these three first columns, basically of the columns of all the columns of data set except the last one. Let's do this. First, what you're going to do is take your data set, that exact same variable which you created in the first line of the code here, data set. Then from the data set, we'll add a dot because we were about to use a function. One of the attribute functions of a uh, pandas data frame, and that function is locate. I look stands for locate indexes. And therefore, what this function will do is it will take the index of the columns we want to extract from the data set. Not only index of the columns, but also the index of the rows. And actually, we have to start here with the rows. We want to get all the rows into X. We only want to take the first columns and we want to keep all the rows. And the trick to take all the rows, whatever data set you have with whatever number of rows, is to add here colon. Because the colon in Python means a range. When we specify a range without the lower bound and neither the upper bound, that means in Python that we're going to take everything in the range. Here, all the rows. So that's the trick. That to take all the rows, you'll always have to take all. We will use that column. You won't have anything to change then. Now we have to specify which comes, one to select with the index and to separate the rows that we just took from the columns. We need here to add a comma. And now we can take care of the columns. So now I'm going to show you a trick in order to take all the columns except the last one, because most of the data sets you will use to train your models will have first the features in the first columns and the last dependent variable vector in the last column. So now we're going to use a trick. We can take automatically, regardless of the number of columns in your data set, all the columns except the last one. The last one are exactly the matrix of features, or except the last one. To do that, add a new range here, which this time will be colon minus 1. So what does it mean? The colon here means the range. So we know we're taking a range here on the left. We have nothing, or that means that we're taking the first index in the index 0 because index is in and start at 0, and then we're going up to minus 1. So what does this minus 1 mean? It means that the last column, minus 1 in Python, means the index of the last column. However, and that's a very important principle in Python, which you must absolutely know, a range in Python includes the lower bound, therefore including here the lower bound 0, index 0, but excludes the upper bound. And therefore here we're excluding this index minus 1, meaning the index of the last column. And therefore, what this will do is it will take all the columns excluding the last one. And that's exactly what we want for our matrix of features, X. So there you go. Now you just collected the right index to create a matrix of features X. And the beauty of this is that you won't have anything to change when creating the feature matrices of features X of your future datasets. But make sure that your future dataset indeed have the features in the first columns and had variable vector in the last column. So in order to finish the line of code, we just need to add here that values, and this just means that we're taking indeed all the values in all the rows of this data set. And all in the columns except the last one of this data set. And now let's do the same for our dependent variable vector. This will be exactly the same, we'll just have to change one little thing. To copy this and paste it paste it right here. And now, according to you, based on what I've just explained, what we do have to change here in order to get the dependent variable vector is most of the time in our data set, indeed, the last column, we have to take our data set because we want to extract this column from our data set. Then we have to use to collect the index for the I look of the rows and columns we want. Then we indeed want to take all the rows of the data set because we want to take all the purchase decisions of these customers, whether or not they decided to purchase yes or no product. So we want all the rows, but then which comes that we want to get here, we only want to get the last column. So according to you, what is index we need to input here in order to get only the last column. We only want to get one column, definitely don't want to get a range. And therefore, I'm going to remove the range here, and then what we are left here with -1. As I've told you, -1 is exactly the index of the last column. That's exactly what we need to create this dependent variable vector. And thus this line of code is done. This line of code, we are getting uh, the the last uh, the last column of our data set. Now you know how to import the data set, create a matrix of features, and create a dependent variable. All Anytime you want to create this for your data sets, you won't have anything to change because this will automatically take all of the first columns for the matrix of features and the last column for the dependent variable. I'm going to show you that X and Y will be well created. In order to do this, we're going to add a new code cell here, inside of which we're just going to print. That's the print function, which allows you to print anything, whether it is a text or an array like X or vector like Y. So we're gonna first print X and then add the new code. Here we're gonna print Y. This is just to show you that indeed X and Y are created with this code. We're going to execute all the cells here because we've just written the implementations, but we have not run the cells in order to build all this. So let's first run this code cell, import the libraries first, and then click here. This one here means it is executed. Time to run the second one. Before running this, you have to do something very important. It is to upload this data set here and see as we format inside our Google Colab notebook. And to do this, you just need to click here, little folder, then upload. Then you're going to go to this whole machine learning folder containing all the codes and data set and which was provided to you um, in your LMS, and give inside this folder, you're gonna go now to part 1, data preprocessing, in order to get indeed that data. And containing the data set we are importing right now, open, and now the data set will be indeed in Google Colab. Now we can run the cell to import it, and it's already import. It is executed. Now we're going to execute this cell in order to print the matrix of features X to check that indeed we get the first columns. And inside this matrix, let's check the data set once again. The first column, meaning the feature as we wanted to get, our first country, second age, and third the salary. These are the 3 columns. And indeed, inside X, we have first the country, the age, and the third is the salary. So that's perfect. We get indeed the matrix of features X containing all the features are also called the independent variables. And now let's run the cell to print Y, the dependent vector, and it gets the dependent variable vector containing all the decisions whether or not the customers purchased the product. So we can check here, yes, no, so on. That's in the same order. We now have our data set, features X and the dependent on Y. We, we create these two entities because the way we're going to build our future models expect exactly these two entities in their inputs. And therefore, not only you improve your knowledge of machine learning, but you also now know how to import its data set and create a matrix of features in an independent variable. We're going to proceed to the next step, which is a new tool which I'm going to show you, and that is taking care of missing data. The data that contains some missing data right here, you can see this is an empty cell. So we will handle that case, which happens most of the time in data sets. So now let's add a new tool to our to our data pre-processing kit, which is taking care of missing data. We have a look again at our data set, data.csv. We notice that there is a missing salary here for this specific customer from Germany, 40 years old, and who purchased the product. So you don't want to have any missing data in your data set for the simple reason that it can cause some errors when training your model, and therefore you must handle them. There are actually several ways to handle them. First way is to just ignore the observation by deleting it. And if you have a large data set, if you have only 1% missing data, removing 1% of the observations won't change much the learning quality of your model. So 1% is fine, but sometimes you have lot of missing data. Therefore, you must handle them the right way. So that was the first way to ignore them, to remove them. And the second way is that we're adding right now in the toolkit is to actually replace the missing data. The missing value by the average of all the values in the column in which the data is missing. So missing salary, we want to do is replace this by the average of all the salaries. This is a classic way of handling missing data. So here you go, taking care of missing data. Let's create a new code cell and let's replace that missing salary by the average of the salaries. To do this, we're going to use the libraries. I'm about to introduce you to one of the best data science libraries, and that is the Scikit. Learn Scikit or Scikit-learn is an amazing data science library containing a lot of tools, including a lot of data pre-processing tools. We'll actually use Scikit-learn a lot in this course. More than half of the models we will build in this course will build with Scikit-learn. If you don't know Scikit-learn, you're going to absolutely love it if you research it. And so far for the first time here, we're going to use scikit-learn to handle missing data. And the class that we're going to use from scikit-learn is called simple input. First, import that simple input class, then we'll create an instance, an object of the simple input class. This object will allow us to exactly replace this missing salary here by the average of the salaries. Then we will have an updated data set, actually a matrix of features, because we will apply this input here on the matrix of features only. We'll have a new matrix of features with no missing data because the missing salary will have been replaced by the average salary. First, the class belongs to scikit-learn. We're going to start here by going from uh, sklearn. First, the class belongs to scikit-learn. We're going to start here by going from uh, sklearn, which has the name as the next step is to create an instance of this class, which you can exactly see as the tool itself. The tool that you'll use to replace that missing salary by the average of salaries. So since we're about to create a new object, we have to introduce here a new variable, and we're gonna call this variable imputer, which will be exactly this object of the simple imputer class. We have naturally to call this class simple imputer. So copy this and paste here. You simply call the class, then you add some parentheses, and you're going to enter the right arguments in order to replace this missing salary by the average of salaries, because there are actually many replacements. You could use the median salary. There is a difference. You could also replace the missing value by the most frequent value. For example, relevant for categories. We have many options, but the most classic one and the one that is recommended is the average salary or the mean. So that's exactly what we have to do to enter here. We have to specify which missing values we have to replace. That's why we have to enter here first argument called missing values, which has to be equal to NP, the NumPy library dot none. Let's just say that we want to replace all the missing value in the data set like this one. This is like an empty value. This is what this means, an empty value. And then the second argument we have to input here is the one saying that indeed the missing value is here. The empty values of the data set will be replaced by the mean. And to do this, we have to add the next argument, which is strategy equal to Encode mean. That's just to say that we want to replace all the missing values in the matrix of features by the mean of the feature itself. Then remember, this is just an object. We haven't connected anything yet to our matrix of features. So the next step is to apply this imputer on the matrix of features. Remember that a class contains an ensemble of instructions, but also some operations and actions which you can apply to other objects of variables. And these are called methods. They're like functions. One of them is the fit method. The fit method will exactly connect this imputer to the matrix of features. In other words, when this fit method will do uh, is look at the missing value, the salary, it will compute the average of the salaries. That's simply what it will do. Then will not be enough to do the replace. We want to do the replacement, we'll have to call another method called transform, and which will apply the transformation, meaning it will replace the missing salary here by the average of the salaries. Let's first call the fit method. In order to do this, we have to call first our object imputer, and then from this object, adding that, we will call the fit method, which has some parentheses because it's like a function inside of a class. And what does this function expect as arguments? It simply expects all the columns of X with numerical values, but only the ones with numerical values, not the ones with text or strings categories. We get this column. Let's get a matrix of features X because that's where we want to replace the missing data. From this matrix of features X, we're going to look at all the rows. This fit method will read the whole column that we specify inside this method. For the columns here, we could specify all the columns where to look for missing data. The first column, uh, or it is a column with strings. This might cause a warning or an error. Therefore, we were only going to specify the columns with only real numbers, age, and salary. We're going to enter the range from 1 to be careful not to, because remember the upper bound of a range and Python is excluded. If we exclude 2, this to the salary, therefore we have to go up to 3. Fit method, uh, we are specifying specific columns, which are the age column and the salary. Because we know that there is a missing salary, there is also a missing age. The general rule to select all the numerical columns, because in your uh, or y- we will work with huge data sets and won't be able to see where the missing values are. Include all the numerical columns to make sure to replace any missing data. Exclude these ones to string columns. Just something important to consider. Connect our imputer to our matrix of features. Then call the transform method once again from our imputer object. This transform method will exactly do that replacement of the missing salary here by the mean of the salaries, and same for the missing age. It will replace the mean by the mean of all the ages in the age column. So what do we have to, or uh, we have to input the columns of X where we want to replace missing data. These are the age column and the salary column. We simply have to input exactly the same as what was input in the fit method. Take this, copy and paste that inside the transform method. This transform method actually returned the new updated version of the matrix of features X with the two replacements of the missing salary and the missing age. Therefore, we want to do uh, is update our matrix of features X. Since this exactly returns these two columns here with that replacement done well, what we want to do to update X is take the second and third column of X matrix features and change it by what will be returned by this transform function of the input object, so that the second and third columns of X will be replaced with that average age and average salary. Therefore, the whole matrix of features X will be exactly the same, but with this new average age and average salary. We're gonna check that right away. To do so, we're gonna create a new code cell. We're going to print the new matrix of features X and see if indeed that missing value we can clearly see here as once again replaced in this new version of X. Not forget to run these two cells here. This first cell to indeed replace the missing data. This cell to print the new matrix X. And as you can clearly see, that missing salary is in the previous matrix of features X and replaced by the average salaries of the column. You can check on Google spreadsheet or Excel this this 63,777 corresponds to the average of actually these values. Check that if you want. Now you have another tool in your data pre-processing toolkit. You have to use it several times when pre-processing your data sets to build machine learning models. Now you're going to proceed to a new tool which is to encode categorical data.